In this video, I'll be solving the integral from 0 to infinity of ln of x over 1 plus x squared. The way I'm going to solve this integral is I'm going to break it up into two separate integrals. The first integral is going to go from 0 to 1, and the second integral is going to go from 1 to infinity. Let's start with the integral from 0 to 1. I'm going to let u equal 1 over x, so du will be negative 1 over x squared. Right now my limits are in terms of x. I have x equals 0 and x equals 1. To find what the limit for x equals 0 is, I'm going to set a limit as x approaches 0 from the right, because at x equals 0, 1 over x is undefined. And because I'm looking from x equals 0 to x equals 1, it makes sense to approach 0 from the right. So a good way to solve this problem is to picture your equation 1 over x on a graph. So as x approaches 0 from the right, it's positive infinity. And as x approaches 1, we get u is equal to 1. So now I can rewrite my integral in terms of u. At this step, we see that we have negative 1 over u squared. We can bring out the negative, and we can distribute the u squared in the denominator. So the u squared can multiply 1 and the 1 over u squared. When we do that, we get negative outside, and then in the numerator we have ln of 1 over u all over u squared plus 1. The ln of 1 over u can be rewritten as ln of 1 minus ln of u. Ln of 1 is just 0. So it'll just be negative ln of u in the numerator with u squared plus 1 in the denominator, and then a negative outside. Let's bring it all together. The original question was to solve the integral from 0 to infinity of ln of x over 1 plus x squared. In the previous steps, I broke up the integral into two pieces. I broke it up from 0 to 1 and 1 to infinity. In the previous slide, I was able to show that the integral from 0 to 1 is the same thing as the opposite of the integral from 1 to infinity. So when I add that to the integral from 1 to infinity, those two will cancel out and I end up with 0. So the integral from 0 to infinity is 0.